Today we're going to be working with inverse functions. I'm going to be doing the left-hand side, so all of the odds. And if you can try the evens to get some practice. And I'll show the answer key here in a moment. Okay, now let's get started. So first, as we're going through to find your inverses, we have f of x here. So our first thing is to switch f of x to y. So now you have y equals negative 2x cubed plus 3. Our next step is to switch your x and your y's. So these are going to reverse. So now y becomes an x and x becomes a y. Now the process of switching your x's and y's means that we've switched your domain and range. So that if we were to ask, hey, what is your domain here? What is your range? That we would be able to see that reversal because we've done this process of switching your x's and y's. So now, once we have everything switched, we're going to solve for y. Just as this problem has f of x or y equals, we want to get y alone to one side. So the first thing we're going to be doing is subtracting out a 3. Next up, we want to separate your coefficient from your y. So let's go ahead and divide by negative 2. So now we have negative x minus 3 over 2. There's lots of different ways to write this expression. So this is just one different way to write it. You could separate them out to say negative 1/2 x plus 3 over 2. That would be another one. You could have one that implies that there is the negative that's on the outside, x minus 3 over 2. But make sure that I'm a huge fan of parentheses, so I would still include the parentheses here. And the last option is to actually distribute the negative throughout your parentheses. So now you switch your signs. So now let's go ahead and solve for your y. So now that y is all alone and to one side, we still have to use the cube. So let's try and lose the cube by doing the opposite. So we're going to cube root your function. So we're now y is equal to the cubed root of negative x plus 3 over 2. Now the last thing we need to do, I'm sorry, I forgot to put up what we were doing here for step 3. So step 3 was solve for y. You'll see these steps here. And then your last step and most important step is to switch y to f inverse of x. This is how you say inverse. Of x. So your very last one, we now have f inverse of x is equal to the cube root of negative x plus 3 over 2. Well, let's try it again with g, or 3. So looking at your 3 here, right? Again, step 1, we want to change your g of x into y. Change your x to y and y to x. And then go ahead and start solving for y. So we want to get y alone. So the easiest way to do that is first subtract the 2. And now to undo your cubed root, we want to do the opposite, which is now cubing it. Now, if you don't know why it's the opposite, please go back to chapter 1.2. We've also see it in chapter 1.9 as well towards the end as to why we are doing some of those things. So we'll cube it. x minus 2 cubed is equal to y. So now that we have y all alone to one side, we now get to say that we have the inverse. Now let's look at your next one. 4 plus 1 over 3x. So again, let's change f of x to y. Switch your x's and y's. Now start to solve for y. So get this y alone. First thing to come over would be this 4. Now, if you don't like the way that this y is written, keep in mind this is also saying y divided by 3 here. So the opposite of division would be multiplication. And what you do to one side, you have to do to the other. Now, notice I opened up a pair of parentheses. That is because each and every term has to be multiplied by 3 in order to keep your equation balanced. Now that is one alternate answer if you wanted to distribute your 3. This would be another answer. But now that y is all alone into one side, we can then go ahead and say f inverse of x is equal to 3x minus 12. I would likely do this one because it looks more of like a linear take on this function. So this one is probably the better option. So hopefully you guys are getting some practice trying 2, 4, and 6 after some of those examples. Now let's try some more on your next page. So this is, when it comes to this particular one, this is a rational function because your variable now is in the denominator. So far, we've had them in the numerator without much trouble. However, now that we are in the denominator, we just have to take a few extra steps. Now, your first 3 steps are still the exact same. So having y mixed into the equation, switching your x's and your y's. Oops, I almost didn't switch that one. Now, again, we tried to go and solve for your y value here. So the first thing to come over should be that -3. So let's add 3 to the other side. You want to isolate your variable term, this whole thing being one term. We want to get it alone to one side. So you have x plus 3 is equal to -4 over y plus 1. Now, back in chapter 1.9, we talked about the easiest way to get your variable out of the denominator, and that would be by multiplying it out. Now, it's not as easy as just multiplying this y to one side and just saying that this cancels and this is -4 over 1. That's not how it works. This y is directly attached to that plus 1. These are working as a team. That's why when we were talking about when to cancel out your denominator like this, we can do so by multiplying by itself. So y plus 1. Right, now that you have 1 on top as you do on the bottom, then we can cancel out this way. Now this is coming directly from chapter 1.4 and again in 1.8. So we can do that over here to one side. Now, I would also encourage you to put in parentheses over here. So now we have y plus 1, x plus 3 is now equal to -4. Now, again, we are trying to solve for your y value here. We want to get y alone. Now, some of you might take the approach of then starting to FOIL, but keep in mind, if you were to FOIL this, you get xy plus 3y plus 3, or sorry, plus x plus 3. That is an okay take, okay? So I'll show you what happens here if you were to use that approach, is that now that you have distributed, in fact, not factored, but FOILed, you now have to isolate these two y values. So that means getting all of your values that are not y alone into one side. -x minus 7. And then again, you have two y's. We need to solve for your y, so getting it alone, we have to factor out first your y to get this x plus 3. Alone to one side. Now we can go ahead and place it over there. So negative x plus 7 over x plus 3. So it is perfectly fine to do, oops, I highlighted the wrong thing up there. It is perfectly fine. I should not be talking and highlighting at the same time. It's perfectly fine to FOIL it out and continue. Your answer might look a little bit differently than what we're going to be doing over here on this side, but notice that notice that we have this x plus 3, which funnily enough is also on the other side. Now what we can do here is save us a little bit of trouble. We can divide by x plus 3 here, and what you do to one side you do to the other side. Now that allows us to cancel out what we have on this side. So we have y plus 1 is equal to negative 4 over x plus 3. And again, we're trying to solve and get y alone. Y is equal to negative 4 over x plus 3. And we're subtracting 1. Now, this would be a perfectly fine answer for me on your quizzes or homework or things like that. Others, they might require you to actually make this into a common denominator, in which case we're using what we know from 1.4 to then multiply on that side. And then you can combine your like terms. However, these two are perfectly fine. They mean the same thing. So the last thing we want to do is say f inverse of x, and then whichever function that you chose to do. This way is a little bit quicker, as you can see. This one does involve you to distribute throughout by foiling and then factoring a little bit more. So after that, probably 8 would be a really good one to practice, as well as, well, we'll do this one when you have multiple of one side. All right, so let's do another one over here. Y is equal to negative x minus 2. X is equal to negative y minus 2. Solving for y, getting y alone, we're going to add your 2 to the other side. And then divide by a negative 1. So now we have negative x minus 2 is equal to y. And the last thing, f inverse of x is negative x minus 2. Those ones are pretty nice. Now let's see what happens with number 11 when you now have multiple variables, one in the denominator and one in the numerator. Again, they can't just cancel. And then you have 4 over negative 2, which is then negative 2. That's not how this works. Again, canceling can only happen when you have the exact same thing on top as you do on the bottom when it comes to a bi, tri, or polynomial. So first thing, it's already in y, that's great. So the next thing we're going to do is switch your x's and your y's. So that step still remains the same. Now we're solving for these y values, one of which is in the denominator. So we don't want to be working with fractions. We don't want a variable in the denominator. So we're going to multiply it out. So we're going to multiply that whole thing to one side. Oh, and that cancels over here. So you now have y minus 2 times x is equal to y plus 4. Now, again, what we just talked about, we don't want to have any sort of fraction or anything that looks like a fraction. So unfortunately, we can't divide by x here. We can't, excuse me, divide by y minus 2. Instead, our only course of action is to distribute your x throughout the problem. So we're left with xy minus 2x is equal to y plus 4. Now that you have two y values, we're going to do what we did up here and try and get them alone to one side. And then we're going to factor it out and divide by the leftovers. So over here, it doesn't matter which side you bring your y's to. I'm going to choose to bring my y over here, my 2x over here. So if x, y minus y is equal to 4 plus 2x. And again, we have 2 of something, so we get to factor out your y, leaving behind x minus 1. If you don't know how to factor, please see some of those factoring videos or chapter 1.3. Now that you have your y solitary, right? You now have only one of them. The easiest way to get it alone is to divide by that whole thing. So if y is equal to 4 plus 2x over x minus 1. And the last thing we want to do is the F inverse. Some alternate answers you could separate and have each term have its own denominator. So another one is 4 over x minus 1 plus 2x over x minus 1. That doesn't look great, but some of these might have a different look on the answer key, but they should be the exact same. All right, so that concludes this video. Hopefully it gives you some practice getting your inverse.